and thank you for joining today's session. My name is Josh Thomas, and I'm currently leading engineering and architecture for commerce and financial systems. Over the years, I worked on subscription billing, payment optimization, and large-scale enterprise integrations across platforms like Zora, Recurly, Stripe, Oracle, and Salesforce. Today, I'm excited to share how platform engineering principles can transform payment systems from a cost center into a real competitive advantage. Going to the next slide, start with today's agenda. Here's how I will be spending the time on this presentation. We'll start with the evolution of payment infrastructure, how we have gone from monolithic processors to distributed event-driven systems. Next, I will walk you through the core principles of platform engineering applied to payments. Then we will look at how to design for resiliency because payments will fail, and the key factor is like how you can do payment failure recovery. After that, I will highlight the observability and compliance part of things, two areas where I think the teams are usually slow down, whereas if it's not built into the platform, but if it's built into the platform, it can accelerate delivery. And finally, we will talk about scaling across different business models, B2C, B2B, usage-based billing. By the end of this talk, you will see how modern platforms can directly drive revenue, retention, and customer trust. Okay, so to start off with, we can see like how a traditional payment system versus a platform driven approach looks like. So these are some of the differences you can see. So traditionally payment systems were seen as an unavoidable cost of doing business. They were brittle, manual, full of tribal knowledge locked into specific teams. Adding a new feature or a payment method took months. And when some failure happened, there was like no visibility into what went wrong. Whereas in contrast, like if you look at a platform-driven approach, you can see we build like self-service infrastructure that abstracts away complexity. The automated recovery process that are built in doesn't need firefighting, right? Because everybody knows when the system goes wrong, and then we can easily start looking at what is the run book and then see like how we can start the recovery process. So we reduce the friction and product teams can fast launch much faster, right? So these are something that are there. Because of this, I think you don't have to worry too much about things going wrong. You can always focus on what next to add or what features to be added, right? So payments will stop being becoming a overhead and they will become a lever of growth. Moving on, so we can look at what happened, right? Like an evolution of payment infrastructure. So let's take a step back and see like how payment infrastructure has evolved. We started with the monolithic processors, one provider, tightly coupled system, zero flexibility. As companies expanded, they integrated multiple providers, payment processors like Braintree, Stripe, Ardian, but each required custom integration code, leading to duplicated efforts. So one payment processor will work one way, the other payment processors will work another way, right? So it was a mix of a lot of APIs and different architectures. So then next stage was evolved into like more API first services. Providers began offering abstraction layers and teams still had to handle all the failures, but still it was a good step in the right direction, right? But today leading companies are more looking at like event-driven payment platforms, right? Where like it's distributed architectures, recovery, observability, and self-service are baked in from the start, right? So the shift is really clear, like how things have evolved from a monolithic to more like event-driven payment platforms where like you get notified of whatever happens, right? So that's what brings in the structure in the payment infrastructure. So moving on, we can look at like core platform engineering principles for payments, right? So one of the things that we always look at it is how can we abstract away complexity so that it's not really part of everything, right? So product teams really need not know like everything, every minute details of say Visa, MasterCard, or local payment method, right? So how can we really abstract all those things in the engineering layers, right? So second, like how we can build like a self-service by default, right? So that like engineering teams are not involved in each product launches or pricing changes or payment method launches, right? So it's more like configuration based that any product team can do. So third is like compliance, right? Like how do you make sure treating like regulations as a separate process where we have a lot of that UAT and backend process? How can we directly embed them into the infrastructure and the APIs have proper auditing and logging, right? And then how can we really create a paved road, right? Which is like optimize default common payment scenarios while allowing flexibility where needed, right? So basically building not over complex systems, but building a system in such a way that we can customize as needed, but not to support like over customizations, right? So that it's easy to maintain the code as well. So looking at the architecture, right? So let's look at like how what all things are really needed in a payment platform, right? So one of the things that we always look at is you need like a gateway, right? Like unified interface that can abstract multiple providers. So say in the case of Stripe, Braintree, each of them has different APIs and different way of handling things, right? But if you have a gateway which can talk to that, it's more like providing that flexibility, right? So from a engineering standpoint or from a product standpoint, you have a payment processor or a payment provider, and then you just call the same payment gateway. And payment gateway has a complexity to make those transformation that is needed for each of those processing layers. So that's one way of abstracting it and then having a unified interface. Then subscription engine, right? So subscription engine is the core of a subscription business. So where like you start creating the subscriptions, and each subscription has like a life cycle, right? So you have, it can be a monthly, it can be an annual, it can be a bundle or like different pricing for price points, right? Baked into the subscription. So subscription engine has abstracts all the logic of making sure like you build the right customer at the right billing period and consolidate that, have if there are discounts, take it into consideration, taxes and other stuff, right? So that's the responsibility of subscription engine. And then event processing, that's core for any system, right? So whether it is like a third party systems or like systems within, right? If then there is an action happening, say like an order is created or like a subscription is renewed, right? That sort of becomes like your event, right? And then that based on that event, you may have 5 to 10 actions to take, right? So maybe like sending out a notification, sending it for payment collection, making sure GL is posted, and then the revenue is also allocated, right? So there are things which can do, which need not be like really tightly coupled synchronous transaction process, right? So this can be an event-driven process where like all the systems or microservices get notified and then they can do the step that is needed of them, right? So, and last part is revenue recovery, right? So AV systems, right, there will be failures, right? And in case of a payment, usually once you have a subscription, you have a payment method that card could expire. There may not be enough amount in the card to make the payment. So there are multiple use cases that can happen. So it's always good to have an automatic retry mechanism built into the platform so that we are able to collect the amount and recover the revenue from the customer. Moving on, how do you really build resilient systems, right? So one of the things that we always see is like payment services always need to have 99.99, right? So it can be like 5 nines or 3 nines or like a single nine, right? So that's the minimum that is needed because anytime there is a downtime for the payment systems, you can see how it impacts, right? So if you look at this, even the single nine, right? You can have only 8 hours of downtime per year. That is like across 365 days, right? So the systems has to be like highly resilient. It has to be reliable. It has to scale on its own based on the customer needs as well as the traffic on the site, right? And other systems should not be able to bring it down, right? So that's a core in that. And there are multiple services involved in this payment flow or checkout process, then we have to make sure this applies to all the services, right? So it's not like only one service being up and running, like whatever services are there in the order to cash flow, they have to be all up and running. And it needs to be resilient all the time. So how do you really achieve this? So one of the things that we can always think about is like, how do you really try to do circuit breakers, right? So if you think like there are some systems failing, like how can we really not add too much of load into those systems, right? And then start throwing error right away so that we don't bring down those systems as well, right? So that is one way to think about it, right? And then how can have like a fallback processing, right? Because sometimes the customer would be having the money in the card, right? It may be some other process that failed on our side. So how do you make sure like you instead of having the customer go through the entire flow and doing a checkout, how can we make sure like we can do reprocessing on our side, like a fallback processing, give them access to the product and then maybe collect the money at the later point of time. So how do you build like compensation handling or fallback processing, right? So that's something that will be really useful when you think about it. And then Other thing is like more of on like on the retry logic, right? How do you really think about retry? How you can learn from the all the failures in the system, try to look at the data that we have and then see how we can build like an intelligent processing, right? With AI in mind, it's always good to have those models learn from the data that you already have and then come up with a model which can predict like what is the intelligent retry or what time to retry, right, for those payments to be successful. So there is a lot of use cases that we can bring AI in when you are thinking about resilient payment systems. So this is like a case study that we have put together, which sort of shows like how it happens, right? So before the platform engineering, 15% of the subscription payments fail on first attempt. Manual retry process, like all best guesses, like you cannot like do infinite retries, right? It always has to be like a way that you retry maybe like 4 or 5 times, right? Like in a 20-day period, because the more retries you do on failed cards, Visa, MasterCard, or any of these payment networks will try to say, okay, you are trying to charge a customer in the wrong way, or like you will be getting fined because you are trying to retry on cases where you are not supposed to retry. So there are lack of visibility into what are the different error codes and then not processing them properly. And then there is no visibility into how the performance is going, right? Like recovery performance. Are we like able to collect most of the payments, or are we collecting on the third attempt or the fifth attempt or the 10th attempt, right? There is no real there is no real visibility into what's happening. And to say the truth, right? A 40% of the recovery rate on failed payments is not a big number, right? So it should be like a higher number because these are customers who are subscribers and they are supposed to pay the company, right? So that's where I think this becomes a what do you call big revenue lever for any companies to focus on and then build engineering around it. So coming back to like how do you get it right? Like with the platform implementation, we start doing like smart retry algorithms and we try consider all the data, right? Because all this failure has a lot of data associated with this, like whether it's from a MasterCard, Visa networks, or from the payment processors. There is a lot of error codes and what you call patterns available, which we can really look at and say, okay, this if the payment this error code, these are retriable errors, and this when retried on say Friday at this time, this could be successful. So those are the things. And then there is always this A/B testing frameworks for retry strategy that could be applied. So you can always bucket some variations, right? Like for the payment retries and then try to learn from them, right? So it's even though the data suggests like as long as unless you try that out, right? Like you'll never know whether how it's successful and how it compares to like our current strategy, right? So it's always better to do like an A/B testing and then figure out what is the winner, right? And then try to do more payment retries in that window. Then it's always a smart idea to have real-time monitoring because without monitoring, it's really difficult to really bring out what is the level of success rate that coming in, right? So like you have to always be on top of it, trying to monitor how the retries are working. And then if there are cases like if we are reliant on an AI model, there are always chances that sometimes it may not be like doing it right way, right? Or the try or the success rates would have started going down. So it's always better to keep track of whether the model is trending in the right direction and then make changes based on that. And if you look at the 78% success rate, like we will bring about close to 40% increase in the success rate, and then that sort of translates to millions in recovered revenue. Okay, so coming to compliance, right? So compliance is something that I think it's always feared in the engineering teams because it adds a lot of overhead to the systems. You have to make sure you audit the systems, you have to build like more data validation or data checks in, right? So it's always a pain to think about like compliance if it becomes like an afterthought, right? But I think if you start thinking about compliance and bake it into the platform, then it becomes such an easy thing, right? One of the things is like a tokenization service. So secure APIs that handles payment data, because one of the things with the tokenization is you are not exposing the customer what you call payment credit card information, right? So it's always best like as a company not to have anything. So that's where I think the hosted fields comes in. So if you are using Stripe, Zora, Recurly, like everybody has hosted payment method field. So like you just have to have their SDK load the JavaScript and then they take care of getting the payment credit card numbers and then they tokenize it for us and then we just use the token, right? As whenever we want to charge the customer or do any transaction on that particular credit card so that we not storing that information, and then makes it easier for our systems to be not non-PCI stuff, right? Because we are not handling any of those data. Then infrastructure as a code. So it's always good to have this infrastructure as code from the starting itself, because with all the cloud PaaS platforms, it's easier to build in a Terraform infrastructure as code ability, so that it's easy to scale, it's easy to spin up new environments, and then put in more rail guards, right? So that not all the engineering team have access to critical data, and everything is controlled by the IAC code and not through manually access through directly through UI, right? So it's easy from an auditing standpoint to really make sure, okay, everything is done through code, and then all the code deployments happen through like an approval process, like a CMC process, right? So that's what it brings in. And then building in the automated compliance testing, right? So we can always automate a lot of these things. We can have frameworks, automated security scanning done like once every month or once every quarter, right? Just to make sure like all the systems are still adhering to all the compliance standards. Moving on, the observability, right? So this is one of the main interesting things, right? In current world, if you need to build a resilient system, you need to know what's happening within your system, right? And if you want to know what's happening with your system, you need to like really start looking at how we can build in observability from the start, right? So if you are looking at platforms like Splunk, Neuralink, right? Like they give us a lot of visibility into what's happening within like the containers, like the CPUs, what is the CPUs, what is the memory usage, right? So if they are not enough, or are they spinning up new instances because the current instance size is not able to handle, right? So all these things need to be monitored so that we can be sure we are building in the right direction. So that's where I think the it has to be part of all the services that we build in the engineering landscape, right? So that we know what is the health metrics and what is the app deck score. If there is there a higher error rate, are there any anomalies? So all this can be identified. And the good thing with having the proper observability is like you can notify the right people at the right time, and then the team to come in and then look at the errors. It's easy for them to look at, okay, trace the error and then figure out, okay, this is because of this issue. So let's either roll back the changes or increase the instance size or like the memory, right? So that's how you think about it, right? So that's where observability becomes very important, so that you can easily identify issues and then take resolution steps, right? As and when an issue happens. So how do you really scale payment platforms across business models? So there are really three core business models, right? One is like B2C, where I think you directly deal with your customers. So any customer that lands on your site, if they want to buy a subscription or something, you are directly dealing with the customers. So there will be millions of customers, millions of payment methods, a lot of transactions happening, right? Because it's like a B2B. In those cases, I think we'll have to really track like how the user is progressing through the funnel. How do you really do A/B testing based on different flows? If some people like different payment methods, right? Is it better to have a different payment method highlighted here versus another payment method? So based on platform, geo, like we should be able to surface different payment methods. Localized payment method is like also one of the important things, because a lot of when you become a global company, a lot of the payment methods that people are familiar in US may not be the same ones that is very famous in other countries, right? So it's always needed to look at those platforms to enable those localized payment methods. For India, it's UPI, and for Mexico, I think Mercado Pago. So there are like different things, right? And then how do you make it simplified so that there is not much hoops in that. The second thing is like B2B enterprise platforms. This is like more enterprise to enterprise, right? So your customers are enterprise, where they are trying to, like when the sales team is trying to pitch them, okay, hey, these are the products that we are selling. This is the pricing or the product catalog. And these are the different combinations, different products that we sell. And then this may be like a combination of one-time charge, setup fee, subscriptions, along with amendments and some usage based, right? So these are something that they try to sell customers. So here I think it's the complexity is more on the billing hierarchy. It may not be the number of what you call subscriptions. This will be more on the complexity of how the products pricings are handled, and then how do you really integrate it with if there are procurement system, supply chain, and other things, right? Like those are and multi-entity invoicing capabilities, right? So that's the complexity there. One of the things, like other thing is like usage-based billing, right? So this can happen for both B2C and B2B. So this is like getting like really what do you call used by all the companies because of the way Gen AI has come out, right? So everybody is talking about tokens, and a lot of things are all like now based on usages, right? So like there are different models even in the health industry where I think if you're using like these many number of sessions, then how do you build the customer, right? Or do you build the insurance, right? So that a usage-based billing is important, where I think on one side you have to track like what are the usages, different usage patterns of the customers, and how do you really map it to like the systems, right? Like the subscription platforms where I think the usages can be mapped to how much they need to be invoiced, right? So that is something. And how do you really use the new predictive billing kind of thing, and how the pricing rules to map this usages to the billing side of things. Moving on, so I just want to spend a little bit more time on the usage-based billing, because I think that's where a lot of teams have felt complexity. There is a high volume event ingestion, right? Because usages can happen, like in the case of, like, say, just the token-based things, right? Like that we have people use APIs. So you have to keep track of it, and there will be a lot of events coming in, right? How do you really aggregate all this data across different systems? How do you have these complex metering abstractions for various patterns? How do you do daily load or a monthly load? That's something that is always tricky, right? And so one of the things that we do, like from a platform side of thing, will be like to have predefined dimensions and metrics, and then having a self-service way of dimensions that we can register, so that everybody can say, okay, this much is mapped to this much, and then also give them like the usage estimation API so that they can self-service, and then even the customers can see how much they have used and then how much they have to pay, right, in the next billing cycle. So that for if the billing is like upfront, then they have to make sure, okay, we cut access and then they pay more and then they get more access. So that's the way that we are thinking about it. And then this is becoming the norm nowadays. So that's where I think everybody is interested in knowing how to really do like the usage-based billing. And how do you think about like building from a developer experience perspective, right? Like for payment systems. So it's always like a API first design approach. So I think that's like a pattern that has been around for years, and all the developers are really accepted this, right? And then people are familiar. Everybody knows how to use APIs, REST APIs, or GraphQL, right? So this is like pretty common standard nowadays, and also like developer tooling, right? So people like it's if you want people to start using in their own languages, and it's always good to have build SDKs. So SDKs or CLI tools and sandboxes are a good way for bringing in new developers to start interacting with your product or start building against yours, right? So whenever you start building, like with again, say like you want to build an integration with Stripe or Recurly, like you always try to see like whether there is an SDK that we can just directly integrate, right? Just import the SDK and then start building. So you don't have to write like that less code, right? Of like transforming the REST API or the request and response. So one of the things important is those SDKs has to be maintained. So that as soon as like the new version comes in, you have to make sure like the SDKs or like CLIs are updated, right? That's the thing with it. But I think that's one good way. The documentation, that's always important, because anybody, if you don't have a big support team or anything, right, it's always better to have a proper documentation, so that like any developer can just go in and say, okay, this is the request, this is the response, this is how you call our API, and then it helps you. And then having a developer portal with like best practices, payment resources, the who are the touch vertical key resources, the whom they can reach out to, and there are templates and tools available, right? So these are something that is like across, right? This is not specific to payment system. This is across anybody, any team that you want to work on developing new solutions. This is some best practices. So how do you measure the success, right? Like beyond the uptime, a lot of the things from a platform side is like developer velocity. How do you roll out new features, right? That's something that we try to see, right? Like from an engineering standpoint, how fast can we work on the business initiatives, and how fast we can do, how much effort is being put, so that we are not always asking like engineering teams to do the work, right? How much things can be like done in a self-service way, so that like we build UI based solutions or what you call API based solutions, which I think where product teams can execute on their own, right? So that like the teams are not involved. And then the quality, right? Like how can we reduce the number of incidents that happens, right? So basically making sure like when we are building something, we have proper quality checks in place, regression that can be run, right? So that they are always up to the standards that we are expecting. That's on the engineering side. But coming to the business impact, right? There is always the revenue recovery, which is tied to millions of dollars, right? So always you have to make sure like we are tracking it very closely and trying to see like how much payments we can do that. Other is a conversion, which is more like a checkout success rate, right? Like how there will be like 100 people going through the checkout process. Yeah, if only 10 people are placing an order, that means like the success rate, like 90%, 90 people are like falling out, right, in the funnel. So how do you make sure how we can improve that, right? Is it something that is because of the, what do you call, friction in the funnel? Is that something that we can improve on, right? Are there like things which are not clear to the customer, how to add payment method and all, like how can we reduce the friction? That's something that we always look at. Other than this, like the retention. So retention is really important, and a lot depends on the product also. So like the, if the student likes the product or the customer likes the product, then they will keep coming back, right? And then they will be renewing the subscription. So it's always better to make sure like how healthy is that interaction with the customer, and how can, if the user is not using it for a long time, then how can we really bring him back by sending him notification, giving him like, say, okay, hey, these are the best things like that can, how you can utilize the platform, right? So they're trying to bring him on the product. So we are almost reaching the end. So what are the key takeaways, right? Let's try to wrap up. And then I think this is like, how do you have to like really start looking with developer experience, because they are the first ones who will be trying to interact with all these payment platforms or other things, right? So if the platform isn't usable, like the adoption really fails, right? You have to just always make sure like everything is easy to use. From a design standpoint, I think you have to always design for a failure recovery or resiliency. So because like systems will fail, there will be like, there are so many partners or like interaction that happens on a payment flow. So it's always better to always design for failures. Know what are the failures, like you do like a failure mode analysis, right, FMA, and then try to figure out what are the failure points, and then take actions based on that. Then embed compliance, right, like third one was like, where like, so that like teams are not really weighed down by all this and like PCI related overhead, right? And then always try to the technical and the business metrics, so that a team is aware of what are the business interests that needs to be the core of the system, and then we build towards that, right? So that's what I think. There is always that need to know like what is the real goal of business, and then what are they really focused on, and then how can we build solutions in such a way that it aligns with the business goals. Yeah, so this is like how you move like payments from a cost center to becoming growth engine, right, being the real part of the business. Yeah, so thank you for spending the time with me. I think, hope you guys learned something new, and then happy for the opportunity. Have a good day. Bye.